Okay guys, so let's continue with today's main presentation, which we held by László, who will talk about code sharing between platforms. Please give it up for him.
So, hello, my name is Laci, and I'm from Treasury. I will tell you about sharing code between iOS and Mac. So, before we begin, I would like to do a quick poll. Hands up if... Okay. Hands up if you're an iOS developer. Everyone, yes. Hands up if you're a Mac developer. Okay. 1, 2. Okay, not so much. Okay, so hopefully this will be a helpful talk to all of you. So what I would like to cover today, I will give you an overview, and then this is the solution. This is the minimum that you will have to do to share code between the two platforms. Then we will go to how you can better organize your files to share them, and how can you improve that organization. So we will go further with that, and later I will talk about what you should share and what can you share, and in the end I will tell you about some platform peculiarities. So when you are developing for both iOS and Mac, you want to share as much code as possible to save time and to save development effort. And at Treasury, we are developing apps for all major platforms. We are developing native apps. We have a huge shared code base, the core, that is written in C++. And today I'm not going to tell you to write C++. So let's zoom in. We have a huge Apple platform-specific code base, and between iOS and Mac, we have a huge shared code. And 42% of this code is shared between iOS and Mac. That's not counting the native C++ code. So why this is important is because for iOS and Mac development, you have a lot of things in common. You use the same languages, Objective-C and Swift. You use the same tools, namely Xcode and the Mac. And you use the same frameworks provided by the system. For example, the Foundation or the Core Graphics framework. You really cannot have apps without that. The connection might. Okay. So now I'm going to tell you the minimum you have to do to share code between the two platforms using the native tools. So in Xcode, the minimum is you have to have 2 build targets, one for iOS and one for Mac. This is the minimum. You want to build 2 apps, really, so you need 2 targets. So when we started, we first had the Mac app, and we later added the iOS. So once you have the 2 targets, you have to decide which files, what code you want to share. And this is thing you can do is you just add your files to both targets. So these are when you're building the iOS targets, your files will be compiled with the iOS target, and when you're building the Mac, it will be compiled with the Mac target. And also you can have platform-specific files that are only included with one of these build targets. You can do this in the build phases, settings, or in the file inspector. You just have to take the targets you want to include your files with. And once you have your files, you may need to add some platform-specific behavior or function. For this, you can use if macros to include iOS only or Mac only behavior. This is how you can do it in Objective-C. You can do it similarly in Swift. So far, we have both build targets in Xcode. We added the share files to them. We added some platform-specific stuff if we needed. And what you have to do to finish up is really implement the UI and the other platform-specific things, and I say you're done. And this is okay for small projects. But most of you have larger projects, and it's more complicated. So you have to improve with that. And you can better organize your files. It may seem like a bit chaotic that you have a bunch of files in your Xcode project. Some of them belong to one target, some of them to others, some of them to both. So in your Xcode project, what you do is you have files, you have resources and information to build your apps. And you can have one or more build targets. You have at least two in this case. And the way it works is targets pick the files that belong to them, like I showed you earlier. And some files are shared, some are not. So let's include the shared files into a framework. So what is a framework? A framework is basically a directory that encapsulates shared resources. These resources can be code, but also other files like images, your localizable strings files, etc. And the framework is a bundle. So you can access these resources through the NSBundle class, or just bundle in Swift. And you can use this framework to share code and resources. So how do you create a framework? You add a new target. You already did this when you added your Mac and iOS targets. And for iOS, you have to pick the Cocoa Touch framework, and for Mac, the Cocoa framework. Okay. And once you have the frameworks, you add your shared files to the frameworks, and finally you link your frameworks with your apps. So this is what we had. We had two build targets for the apps, and now we have this. We have two additional targets, one framework for the iOS, one for the Mac. Is it better? It's like 2 times the targets. We have shared files, but 2 new frameworks. Who thinks this is better? No one. Who thinks this is worse? Okay. So most people think this is worse. And you may be right, but in some cases this is better. The shared files are added to the framework, so the shared files are made implicitly independent from other platform-specific files you had in your app. So you won't make your shared files dependent on some iOS-specific file, some iOS-specific class, because it cannot access that class. So you won't make this mistake. You won't accidentally break the other platform. And this improves the structure of your code, and this introduces layers, so you can better separate what is shared and what is not. So I'd say this is better, but but you feel this is not quite right. You raise your hands, you don't like this, so okay, there's things you can improve. So in the Xcode project, we have a lot of iOS-only files, Mac-only files, and a lot of shared files. The project is cluttered with these files. A lot of files only relevant to 1 or 2 targets. And it can happen that files accidentally get added to other targets. For example, you have some really nice thing on iOS, and you use it on iOS. It's added to the iOS target, and you want it on Mac as well. It's really easy to just add that tick, add it to the Mac, and now you have a shared files outside your shared frameworks. So let's go a bit further to better structure our code. Split our Xcode project, one Xcode project, into multiple Xcode projects. This is really easy to do. You just create a new project. You can create a new project anytime you want, not just when you start working on a new app. So let's create an iOS project that is only the iOS app and only the iOS specific files. Let's create a Mac project that is only the Mac app and only the Mac specific files. And let's create a shared project that is only the shared files and the frameworks. But how do you connect these projects? You have 3 separate projects. One thing you can do is Xcode sub-projects. You can add a project as a sub-project to another project. This works, though if you open your iOS project, it will open the shared project as well. And when you try to open the Mac project, the shared project cannot be loaded because it's opening another Xcode project. This is how Xcode works. And also it's a bit complicated that you have 2 separate projects and you may want to work on both apps at the same time. You can use Xcode Workspace to resolve this. The workspace can reference multiple projects, and these projects can be interdependent, so they can depend on each other, and the workspace can not only contain projects but also other files, though those cannot be included as a resource in your app. And to create a new workspace, just go to Xcode Files, new workspace. It's that easy. And once you have your workspace, you just drag and drop your projects in it. And you have your 3 projects in one Xcode workspace with all your targets. And this is better because your different projects do not get cluttered with other platform-specific stuff. It's harder to get them mixed up. And it makes you think, if you have something nice on iOS and you want it to add it on the Mac, you cannot just add that tick and boom, it's there outside your shared frameworks. You have to move it to your shared project, add it there, and it's automatically included in both of your apps. This is also good if you have iOS app extensions. You just add things to the shared frameworks and it's automatically included in your iOS app, your Mac app, and your extensions. So, what to share? What should you share? What should you not share? That's what I'm going to talk about now. But what can you share at all? You can share code and you can share resources. Resources can be images, localizables, like I said before. And so most of you want to share code. So what code should you share? You can easily share model and business logic, code like utility classes. This is quite easy, usually platform independent. When you try to share views or view controllers, that's more difficult. They are very similar in both platforms, but also very different. The classes are different, like UI view and NS view. You can do tricks to work around that. But I still wouldn't recommend it unless you want something very simple. So you should implement any platform-specific stuff outside your shared framework. One thing you can use to you have a protocol in your shared framework, and you can implement platform-specific stuff in classes and make them available at runtime to your framework. You can also use categories and extensions. Like you have a shared class, you want some platform-specific behavior on that class, you add it only in your iOS app as an extension, or only in your Mac app. You can also do this in Swift with protocols, where you can have protocol extensions. It's even more powerful. Oh, and one more thing, it also helps you, when you implement platform-specific stuff outside your shared framework, you have to write less if-def macros, and that tends to clutter your code, makes it hard to maintain, hard to read. So I can only recommend it that implement platform-specific stuff outside your shared framework. How can you share resources? You can add them to your framework as well. You can access the bundle of your framework at runtime using the bundle class. You can see a Swift example. You can get a bundle for your class, for your shared class. So this will give you access to the shared framework bundle. And once you have the bundle, you can really access any resource inside your framework. So like, you can get URL for any resource, so you can access anything, but easily you can access your localized strings and your images. You can also load your storyboards from your bundle. So, to sum up what we covered so far, we added shared files to frameworks. We created separate Xcode projects, separate for your iOS app, for your Mac app, and for your shared frameworks. And we use the Xcode workspace to connect these together. And you can share code and resources as well. Finally, I would like to tell you about some platform peculiarities. This is really interesting if you're developing for iOS and you're new to the Mac and you expect something to work and it really doesn't. So one of the things is UI label and UI text field on iOS. You have two separate classes and you just assign a text property and boom, there you have it. You can even assign nil and it will be empty. On the Mac, you have an NS text field class that covers both behaviors. It's heavily configurable. You don't do it in code. You do it in your interface builder files. And if you're looking for the text property, it's not there. You have the string value, and you cannot assign nil. It will crash. But it doesn't only have the string value. It has int value, float value, and actually all these properties on the NS control class. So you think it's the same, it's similar, but it's also very different. One other thing, I'm sure you use it a lot, we call become first responder, text field, or anything. You're told to do this on iOS. You're told to not do this on the Mac. It is forbidden, it's written in the documentation, do not do this. You do call window.make first responder and pass in your responder. Finally, the view control lifecycle methods is there on iOS since the Stone Age. It's only there on Mac since macOS 10.10. So you usually do a lot of setup in view did load. You like do that? And so if you do that, yes, a lot of you do that. We do that too. So you can work around this. The load view method is there for us. And you can check in your load view method if the view did load method exists. It exists if you're running 10.10 or newer. It's not there, or it doesn't if you're running earlier. And you can override or implement. It depends on which version you're running. The view did load method and you can check if your class responds to the selector view did load. This is a subclass of NSViewController, and we are checking the NSViewController class itself if it responds. So we can either call super or not, and then we have our custom code after it. And if we subclass this base view controller, we have our viewDidLoad method. So, thank you.
So back to your shared XC workspace slide. How does that structure handle third-party dependencies? Like,
I was about to ask the same question.
Yes.
Like, how does it work? Does it work?
I mean,
That's a great question.
if you just want to include something in an iOS project, it's okay, or in a shared. But what if you just want to use CocoaPods?
That's a great question. I do not have an answer for that because we use very few third-party libraries, and we have a lot of problem with CocoaPods. We had a lot of problem with CocoaPods, and we stopped using it like 2 years ago. So it's really up to CocoaPods how it supports, how you can configure which project it should add its dependencies to, or its libraries to, and I cannot comment on that.
I had the same problem before, and I tried to use it with Cartridge.
Mm-hmm.
And I cannot say that it handles really well with the third-party dependencies, like a nasty one in project files. So that's why I asked this question.
Mm-hmm. Yes, it's easier with Cartridge. Yes.
So you have a much bigger overview of the iOS and macOS frameworks in general. What do you think? Are they going the same direction? Will they merge somewhere along the line?
Well, I don't see that much convergence. New frameworks are very similar, but what we had already, like for the UI frameworks, you have the UI kit and the app kit. Those are different, and I don't see any convergence there. So I know there are rumors Apple is planning to merge the two platforms, but I will be very surprised if that happens. Both the UI kit and the app kit frameworks are huge, so it would be a lot of work to implement a new one, yes, or just, I don't know, extend UI kit with Mac specific stuff, and since that is a newer framework, you know that Apple put more thought into it, more experience into it, so it's definitely easier to use than AppKit, but still it will require huge work. So I don't think that it's coming, to be honest.